Welcome back, geometry students. It's Miss Graham again, and we are going to be looking at Lesson 7-1, Parallel Lines and Angle Relationships. Remember, our whole entire textbook is called Parallel and Perpendicular Lines, so this is really getting to the root of it. Our learning targets for today are we are going to make conjectures about the angles formed by a pair of parallel lines and a transversal. So we're going to figure out what a transversal is too. Our second learning target is to prove theorems about these angles. If we look below, we can see a real-life story problem that relates to this. Matt works for a company called Patios by Madeline. A new customer has asked him to design a patio and walkway. The row of bricks in the patio will be parallel to the walkway, as shown in our diagram. So we can see over here that we have our walkway, and we see the bricks are going to be parallel to that. So far, Matt has used stakes to tie down two parallel strings. So I'm going to go ahead and highlight that word, parallel, so that way we can look at that. All right, so he's tied down two parallel strings that he can use to align rows of bricks. He has also used paint to mark the underground gas line to avoid the house, so that he can avoid accidents during construction. The string lines and the gas line intersect to form 8 angles. So we can kind of see that in our picture below. We can see in the margin on the right side that it says two lines or parts of lines are parallel if they are coplanar and they do not intersect. So looking at our picture below, we can see that we have our two parallel lines right here is marked. And we can see it builds off of that walkway. And we can see that there's a gas line that comes through here that intersects those two parallel lines. Let's go to the next page to maybe figure out what that line is called that intersects the two parallel lines, as well as the different types of angles that are formed. Now, if we look to the margin on the left side, we can see this definition of a transversal. So it says a transversal is a line that intersects two or more coplanar lines in different points. So actually, on the previous page, and what I did was I actually copied the picture and I brought it to the corner here. You can see that we have this gas line intersecting both of the string lines. That's actually a transversal. So going back to what we had before, all right, we can see that there are different relationships that happen with transversals. Now, up above number 1, I'm actually going to help you out in filling in the following information. It says use a protractor to measure each of the numbered angles formed by the string lines and the gas line on the previous page. So to help for sake of time, I'm going to go ahead and give you those results right now. Go ahead and pause the video right here to copy down these angle measures. Now, what we're eventually going to do is we're going to look for patterns within these angle measures, because you can see some of the angle measures are the same measure. Maybe some of them you're seeing are supplementary. That's what we're going to look at. So, as we said before, the gas line is a transversal of the string lines. We're going to name the angle pairs formed by these lines that match each description. So again, we're going to have to refer to our picture on the side. So I'm going to go ahead and zoom out, and I'm going to have my picture on the right side. Okay, over here we can see each of the angles that are measured. So looking at our vocabulary word, the next one we're going to come across, it's corresponding angles. In the margin we can see it labeled. It says corresponding angles are adjacent angles. They're a pair of adjacent angles such that the angles are on the same side of the transversal. And one angle is going to be outside the two lines and one angle is between the two lines. Okay, whoa, that's a lot of information that's going on here. Okay, let's break this up. Let's start with the first part. It says a pair of non-adjacent angles. That means it's not going to be any angles next to each other. So looking at our picture, it won't be angle 4 and 1. It won't be angle 1 and 2. It won't be angle 2 and 3. It won't be angle 4 and 3. We can see that those are the angles that are adjacent. So they're not going to be adjacent. All right? And it also tells us the angles are on the same side of our transversal. So referring back to the transversal, remember it's this gas line. Oh, let me try again. It's this gas line right there. They're going to be on the same side of it. So they're either both going to be on the left side or they're both going to be on the right side. So this is helping us out a little bit. So we know, 1 and 4 couldn't be a pair, but maybe we're going to pair it up with some of the other angles over here. So it also tells us that one angle is outside the two lines. So remember our two lines that we have here, right? Our two parallel lines. So one is going to be outside of it. So think of in between the two parallel lines as the space inside here, and outside of it is going to be the space outside here. Okay, so one of the angles is on the outside and one is between the two lines. So let's just look at one of these examples. Let's look at angle 1 right here. We can see angle 1 is outside the parallel lines. So I want to pick another angle on the same side of the red transversal that's inside the two yellow parallel lines that is not next to angle 1. Well, that would be angle 5. Look at that. So we're going to say angle 1 and angle 5, that's a pair of corresponding angles. So right now, what I'm going to have you do is I'm going to have you pause the video and continue to look in this picture to see if you can find 3 more pairs of corresponding angles. Go ahead right now. All right, let's go ahead and see the pairs that you found. I found, if we're looking at the same side of that transversal, I found angle 4 and angle 7 to be a pair. I also found, going on the opposite side of the transversal, I found angle 2 and angle 6. And then last but not least, I found angle 3 and angle 8. Now, we're going to start making relationships, conjectures eventually, but if you look at all the measurements above of angle 1 and 5, you can tell that they are the same to each other. If you look at angles 4 and 7, you can tell they have the same measurement too. Same with angles 2 and 6, they have the same measurement to each other. And then angles 3 and 8, they have the same measurement to each other. So, thinking about this, maybe what we could do is we could start looking at question 3 on the bottom. It says, based on your answers from number 1 and number 2, we're going to make a conjecture about each type of angle formed by the parallel lines and the transversal. So looking at this, it talks about corresponding angles first. Well, I see from this pattern that corresponding angles will be congruent. So I'm going to write that down. I'm going to say corresponding angles will be congruent. We're going to continue this with our 2 other angle relationships as we move on. So let's look at our next new vocabulary word. Same side interior angles. So over in the margin on the left side, it says same side interior angles are a pair of angles that are between the two lines, the two parallel lines, and on the same side of the transversal. Okay. So now we have to come up with what that would look like in our picture. So they're going to be between the two lines, so we know it has to be in between here. Okay, so looking at this, we want to come up with angles that are also on the same side of the transversal. So between here and on the same side of the transversal, that means they either have to be on the left or the right side altogether. What if I did angles 4 and 5? Those are a pair of angles that are between the two lines, and they're on the same side of the transversal. So let's write down that angle pair, angle 4 and angle 5. I want you to go ahead and come up with one more pair of same side interior angles. Go ahead and pause the video here. All right, were you able to figure out angles 3 and 6 were the other ones? I thought so. Nice job. So those are our two pairs of same-side interior angles. Now, if we look above, we can see that this is kind of tricky. If we look the measure of angle 4 and compare it to the measure of angle 5, they're not congruent. But is there another pattern that you notice about those two angles, maybe with a little addition? Do you see that they add to 180 degrees? So that way they're supplementary to each other. Well, let's see if that works with angles 3 and 6. Angle 3, angle 6. Yeah, those add to 180 as well. So maybe down at number 3, it says, okay, we want to, make a conjecture about these angles. Same side interior angles, we're going to see will always be supplementary. So I'm going to abbreviate same side interior angles, just like that, will be supplementary. And remember, supplementary means they add to 180 degrees. So if you need to put that reminder, you can add to 180 degrees. Let's go ahead and look at our last new definition. Alternate interior angles. In the margin on the left, it says alternate interior angles are a pair of angles that are between the two parallel lines and on opposite sides of the transversal. So it's a little bit different from same side interior angles. Alternate means it's going to be alternate. It's going to be on opposite sides of the transversal. There's two pairs of them. I'm going to help you come up with one of them. So let's start looking at this. We want a pair of angles that are between the two lines. So they're between the two lines here, but they're on opposite sides of the transversal. So one's on the left and one's on the right. Okay, so looking at this, let's say I look at angle 4. It would pair up with angle 6 because they're inside the parallel lines, but on opposite sides of the transversal. So I'm going to go ahead and write down angle 4 and angle 6. Go ahead and pause the video so you can find the last pair of alternate interior angles. All right, hopefully you found angle 3 and angle 5. We can kind of see they're alternating, right? And they're on the interior of our two parallel lines. So let's look at these angle measurements now. Angle 4 compared with angle 6. Hey, they have the same measure. They are congruent angles. Let's see if it works up for angle 3 and 5. Boom, we're right. So similar to corresponding angles, we know alternate interior angles will be congruent. Let's go ahead and head to the next page. We're going to go ahead and we're going to look at number 4. You can go ahead and cross out number 5. We're not going to do that one. We're going to skip that one. If we zoom into number 4, we're going to see that we're going to do a little drawing. It says the lines below are parallel. Now, we're going to learn in the future the symbol for parallel lines, but if you go ahead and follow me, I will show it to you. It's actually going to be kind of like a little arrow. It's not in the spot on the end of our line, but we're going to put them on one on the top parallel line and the one on the bottom parallel line. Some people like to fill in that arrow so it looks like a triangle. So that's a symbol to let you know that these two lines are parallel. So even if the directions don't say that, we're going to know in the future that these two lines are parallel. So that's just something to kind of keep in the back of your mind. Now, let's see what it asks us to do. It says, draw a transversal to the parallel lines. So remember, a transversal is a line that cuts through any two lines. Remember, the lines don't necessarily have to be parallel, but in this case, they are. So let's go ahead. I'm just going to draw a line. Let me try this. I'm going to draw a line that cuts through the two parallel lines. Perfect. So I'm going to go ahead and label each of the angles that form. So I am going to do 1, 2, 3, 4, kind of like a clock at each of the 4 intersections. And then I'm going to do 5, 6, 7, 8. So let's say I told you the measure of angle 1. Let's say I told you the measure of angle 1 was 145 degrees. I want you to figure out what are the other angles that are congruent to angle 1, and I want you to go ahead and mark them on your picture. Pause the video right here. All right, as you can see, I marked angles 1, 3, 5, and 7. Now, we've learned that angles 1 and 3, they're congruent to each other from a rule a little while ago. That's vertical angles. If we look at angles 1 and 5, that's one of our new rules that we just learned. Those are corresponding angles. Now, if we compare, let's say, angle 5 and angle 7, we know that those are vertical from each other. We also can see, looking at angle 3 and 7, those are another set of corresponding angles. So that's how we're able to find all those angles are congruent to each other. So I'm going to write down angle 1, angle 3, angle 5, and angle 7. We're going to say they all equal 145 degrees. So what does that mean for the rest of our angles? Well, let's go ahead and let's say I know angle 2, and even though I'm using colors, I'm also going to use different congruence markings just to show that angle 1 is different from angle 2. So that's why I'm putting 2 kind of curved tick marks. So let's say angle 2 is 35 degrees. What do you know about angle 4? Well, you know that's also 35 degrees because of vertical angles. Now, what if I didn't know angle 2, but I knew angle 4? What else could I find? Well, I could find angle 6. I could, because they are alternate interior angles. So keep that in mind. We also know that is going to be 35 degrees. Now, let's say I didn't know angle 6 and I didn't even know angle 2. We know angle 8 would also be 35 degrees because of corresponding angles, right, to angle 4. I mean, we could also do vertical angles with angle 6. So you can see there's a lot of angle relationships here. We can see that angle 2, angle 4, angle 6, and angle 8 all equal 35 degrees. Now, the cool part is, remember, we didn't really talk about same side interior angles. That would be like, I don't know, angle 3 and 6. If we added angles 3 and 6 together, we can see we would get 180 degrees. So that shows same side interior angles are supplementary. This is pretty cool, don't you think? All right, let's go ahead and let's turn to the next page, page 76. What we're now going to do is we're going to look at all of those different types of vocab words, and we're going to change them into postulates and theorems so we can use them in our proofs in the future. Number 6 says the corresponding angles postulate. Ooh, I'm definitely going to highlight that one. Corresponding angles postulate involves angles formed by 2 parallel lines cut by a transversal. So it says, based on your earlier conjecture, write the corresponding angles postulate in if-then form. Remember, a postulate is always in if-then form. Just think back to our real-life situation where we were involving basketball before. So I'm going to help you out with this one. We know if 2 lines are parallel and they're cut by a transversal, then we know the corresponding angles are congruent. So I'm going to say if 2, and instead of writing out the word parallel, I'm going to show you the symbol for that. Do you remember? It's 2 vertical lines just like that. Remember, that's perpendicular. We're going to save that for the future. But if 2 parallel lines are cut, meaning they're, a transversal intersects them. So if 2 parallel lines are cut by a transversal, then the corresponding angles are congruent. Cool, so we wrote a postulate, an if-then form for corresponding angles. Now, part B asks, do you need to prove this postulate is true before you can use it as a reason for a proof? Remember, postulates are accepted as true without proof in geometry. So no, we actually don't need to here. So we're going to say no, since postulates are accepted as true without proof in geometry. Can you think of another postulate that we learned before today? How about the angle addition postulate? Or about the segment addition postulate? Yeah, those are two good examples of what we've learned. Now we're going to look at part 7. So we're going to go ahead, go down to part 7. I'm actually going to have you try 7A on your own, but let's read the question. It says the alternate interior angles theorem and the same side interior angles theorem also involve angles formed by two parallel lines cut by a transversal. So similar to what we did in 6A, I'm going to have you go ahead and look at 7A. Based on our conjecture from earlier, I want you to try to write the alternate interior angles theorem in if-then form. So refer back to what we did in 6A, what you have from the vocab before. Go ahead and pause the video right here. All right, go ahead and check your answer with mine. I said if two parallel lines are cut by a transversal, then the alternate interior angles are congruent. So similar to what we did in 6A. Now I want you to go ahead and try one more time on your own. Based on your earlier conjecture, now I want you to write the same side interior angles theorem in if-then form. Go ahead and pause the video here. All right, let's check your answer with mine. I said if two parallel lines are cut by a transversal, then the same side interior angles are supplementary. So remember, same side interior angles will be supplementary, not congruent. So that way they add up to 180 degrees. Now, something I want you to remember as a side note is that we've been looking at parallel lines. There's not always going to be parallel lines in our situation. So let's say in the margin, I draw two lines that are not parallel. Remember, a transversal can still be a line that cuts through those two lines. So let's say my black line cuts through both of those lines. I could still number each of the angles here, right? But we just have to know that we can have those angle relationships. I could still have, corresponding angles. I could have angle 1, let's try again. I could have angle 1 and angle 5 being corresponding, but that does not necessarily mean they're congruent here. I could say an example of same side interior angles could be angles 3 and 5. Those might not necessarily be supplementary. I could also talk about alternate interior angles. I could say angle 5 and angle 4. They're alternate interior angles, but they aren't necessarily congruent. So just keep in mind, we've been looking at an example with parallel lines, and that's where this theorem comes into place, knowing that some of those angles are congruent, some of those angles are supplementary. But I just wanted you to be informed that we can still label corresponding angles, same side interior angles, and we can still label alternate interior angles even if the two lines aren't parallel. For Ms. Graham's class, we're now going to go ahead and start looking at your homework. Every other class can pause the video right here. For Ms. Graham's class, go ahead and skip to page 78. For homework tonight, we're going to look at page 78. You're going to have problems 14, 15, 16, 17, 18, and 19. I really want to make sure you get some good practice at looking at parallel lines and different angle relationships. All right, enjoy your evening.